Hello everyone. In this lesson, we will look at the game camera document. This chapter should cover some simple examples. Let's just look at the document first. Actually, this is about placing two cameras in the scene and switching between them. But the way it creates them is quite special. The first method is that it creates a new project called How to A2 Camera. So let's call ours Auto Camera. It placed a camera actor in the scene. So it placed a camera actor. This actor is actually just an actor. And it has a component called CameraComponent underneath it. So this is a camera actor. The second method is quite special. It first adds an actor. This actor is actually a StaticMeshActor. Then inside this StaticMeshActor, it already has a static mesh code. You added another component to it, called this CameraComponent. So there are actually two cameras in the scene. One camera is a separate individual, and the other camera, you can see here, it is actually attached to the static mesh. Next to this cube. Then you can adjust some parameters of the camera cover component. Try to match the parameters of the two cameras as much as possible. This way, when switching, it will avoid some unnecessary loss of aspect ratio or other losses in the picture. But you don't have to do this, because sometimes the camera requirements may be different. For example, some of its FOV, the width of this field of view, etc. These should be some blueprint technique. We'll just use blueprint parameters. We won't go into detail about these parameters anymore. And then our scene is already set up like this. Generally, this kind of work belongs to the level artist's work. Then at this point, we start doing the camera view switching. So here, its camera uses a CameraDirector. That is a director-like thing. Note that it does not actually contain a camera. It is actually an actor that controls the view. So here, it first declares two objects. These two objects actually point to these two objects in the scene. And there is a parameter for this time switching. And at the same time, there's a GamePlayStatics here, a static library of such blueprint functions. These functions are actually often called in our blueprints as well. This place includes this header file. It allows us to call it in our source file. Here it performs a time accumulation process. That is, when this time, it should be. Looking at this time, it performs a subtraction process. It's just calculating time. Because for the time here, we sometimes like to do it this way. It's accumulation, meaning after we let this time accumulate beyond this value. We set the accumulated time to 0, then execute the function, and then let it start accumulating from the beginning again. But here, its writing style is a bit more spatial. It does it through cumulative subtraction. That is, this time will keep decreasing. When it is less than 0, we add our interval time, and let it continue to decrease. Only when it decreases to 0 do we execute the function, and then reset the time, and then continue to accumulate this kind of time. This is tick, the work that is executed every frame. Then through this GamePlayStatics, this blueprint built platform library, we got these locally controlled. We generally only have one local player. There is only one local player. Then in this way, we get the player's controller. Then we judge through the controller the player's current view target, whether it is our camera, this camera view. Because, as an actor, when it has a camera view, actually this view targets this camera. This camera thing, we can click in and take a look. And when it is not the first one, switch to 1. When it is not the second one, switch to 2. Anyway, it's a switch like this. Only a rotation between the two. This is equivalent to processing over time. Okay, so it's done writing. So the overall code here looks like this. And then here, and this is its original file. You can see it's basically consistent with ours. Then after he puts this object into the scene, there is a scene object. And then here, because we are giving a pointer like this, note that we are giving it a pointer. And this pointer points to this instance object in the scene. So you need to manually make it capture this thing. Of course, you can also do it like this. Actually, sometimes we use this getActor class to write this logic. And we can also manually capture it in the editor. That is also fine. After capturing it, we play it, and then it can achieve this smooth transition function. So overall, for list chaos, it is roughly this kind of workflow. And one thing worth noting is that it introduces some new operations. For example, sometimes you may have more than one camera. It might be a variable host, right? We will expand on that for you in a moment. Could be 3 cameras, could be 4 cameras, could be 5 cameras. So do I need to go every time? Do I need to manually replenish the cameras in the scene every time? For example, when we are building a scene, we have long distance cameras and close-up cameras, and also the camera on the podium, right? So if you do it this way, actually, this feature of yours, if it is a feature that can be decoupled, then this design is definitely unreasonable. You could make it into a modular kind of thinking. That is, no matter what kind of level, just put your director, that is, the camera director. Then it can switch between all cameras by rotating through them. Okay, finally, let's implement this feature for everyone. And why here? Nancy say not to use an actor pointer to point to the camera. Actually, you can look at the English, because sometimes, that is, the Chinese documentation may have some issues. So how should we handle it? We can just look at the original documentation, which is better. Then copy the original documentation here and switch the language to English here. We'll just scroll to the very bottom, right? So what this actually means is you can wrap it with a struct and then put the blend time into this struct. So here we will also give you a simple implementation. Okay, so we'll stop here for the documentation of this lesson. We'll move on to the practical session in the next lesson.